All right, let me hear from Graham first.
So what I want to say is that the difference from an expression for an equation is that both sides of the equal sign are equal. And may I say one more thing on top
You
of
may.
that? The algebraic expression does not have an equal sign because equation means it has an answer to it.
Okay. Kylie, what were you going to say?
The same thing. I was going to say that
Well, what was the same thing? Because I forgot what he said.
an equation is balanced. So 2x means 2 times x, and if x equals 8, then that's 16.
So there's the balance.
And then, well, the algebraic expression does not have
This
the
goes
balance
away.
side.
It's this. There's no other side. Pramita, what were you going to say?
I was going to say what they said.
Well, what was that?
So an algebraic equation has an answer to it and an equal sign, but an algebraic expression doesn't have an answer. It's just a number and a variable. Or an answer.
So here's the fulcrum. Here's the scale. Equation. Equation. Anybody got a problem with that? You should. That's not an equation. Expression. Expression. Equation. Right? Both sides and they're balanced. Whatever's on this side balances what's on that side. This is not an equation. This is not an equation. This is an equation. Okay, Melis, throw me a mystery weight. Throw it up here at me. Okay, got it. Fred, throw me an X. Okay. Okay. Throw me another of those same mystery equation, those same mystery amounts, Chloe. Okay, I'm gonna throw that one over there too. So there's 3 of those over there, right? All 3 of them are the same. Now, I'm gonna tell you right there is a 24. So what's that X and that mystery weight and that mystery weight all worth? 24. What are they worth separately, Josiah?
8.
How do you know that?
Because if there are 3 things, 8 goes into multiplication.
So he just did algebra. You're like, "Durr, that's not hard." That's all it is. Is you got something where you don't know the amount. You know on the other side of the equation what it's worth. You go through a process to figure out by keeping the balance what those mystery things are worth. The mystery things we call variables. Yes, Lincoln. Yeah, I know. It's fine. Variable. Okay? That is the mystery weight. Okay? The X. They don't call it the mystery weight in a math book. They call it the unknown. Thank you. So does it have to be an X? No. Can it be a triangle? Can it be a circle? Can it be a Z? Can it be a 9? No. All those other things it can be. Because I can assign that triangle or that box or that circle or that X or that Y or that Z or their A, their B or their C or the J or the L or the I. I can assign them a value for that one problem. Then the next problem, their value can be a different thing. Right? They vary from problem to problem. Okay? Let's write that down. These are unknown amounts. They vary from problem to problem. You know vary means change, right? They change. So it's a letter or a symbol. I can use a letter or a symbol. So in that 2x, the variable is which part? 2x, right? No. X, I tricked you. It's just the x. In this 2x, only the x is a variable. Don't we know what 2 means? Is that ever going to change? Nope. Nope. So what's the 2 called? 2. Number. Has another name too. What's its other name? Let me hear from somebody who's not talked. Yep. Yep. That's right. Constant. Never changes. It's a number. It's constantly that thing, right? It never changes that number. Just a second time. It's not going to change. It's going to be that number. No matter what problem I'm in, a 2 is a 2. No matter what problem I'm in, a 9 is a 9. No matter what problem I'm in, 1/2 is 1/2. 0.3333 repeating is always that. Right? Not going to change. Make sense? Now, what do you call it if you say 2 plus x equation, right? It's 2 plus an x. So that would be like saying, okay, throw me 2 up here. Throw me a mystery weight. There they are. Okay, I know there's 2 up here, but I don't know what the mystery weight is. Okay, Chloe, throw me 17 over here. All right. Now I know what that x is worth. 15. Because I had 2 plus the mystery all equals 17. Well, then obviously 2 minus 17 is 15, so that x is 15. I just changed it from saying mystery weight to x. Okay? Now, I'm going to do another problem. Michaela, throw me your mystery weight. Ow! Wow. Okay. Calm down. All right, here's the mystery weight. Fred, throw me another one. Okay? Mystery weight. 2 mystery weights here. Betty, throw me a 7. Okay? Throw me Mason a 1. Okay. Now, what are those mystery weights worth? You just did a 2-step equation. That's past 6th grade. You're like, no, we just played like we were throwing stuff in the air. That's a 2-step equation. There are 2 things happening. There's 2 times x plus 1 equals 7. That's what you just did. That's 2 steps. That's 2 operations. You're like, that's just common sense. Yeah, it is. But that's a 2-step algebraic equation. Those 2 mystery things are 3. There's a 1. All of that's worth 7. Well, obviously those are 3s. Okay? Now, what about if I just say, throw me an x and throw me an x? 2x. It's 10. They're 5. Is that still an expression, though? 2x. Because a minute ago I said 1 plus x plus x, or 1 plus 2x. But 2x, I thought an expression had to have operation sign in it. Don't expressions have to have operation signs like plus, minus, subtract, divide? Courtney, don't they? Expressions, 2 plus 2, 9 minus 1. 3 divided by 7. Right? Can you do 3 divided by 7? Sure you can. You get 3 sevens. Yeah. But 2x, there's not a sign in there. Yes?
But,
Both of you. Talk.
well, at the same time, when there's no sign, you multiply it.
No, I gotta put a sign, right, Kylie?
No, so 2x is 2 times x.
Yeah.
Which is
In algebra land, if it's a multiply, you just put the number beside the letter, it automatically means that. Like, for example, you're like, I got 2 books. Well, that's book times 2, right? Or 2 plus 2, or I'm assuming 1 plus 1 book. Or I can just say 2 books. So I'm just saying 2 x's, that's 2 times x. So when I say 2x, that is multiplying, okay? That is multiplying. So that has a name as well. What is the name of that? If I have a 2 with an x, or a 9 with a y, or 1/2 z, or 7.3a, what do you call that when it's a multiply algebra expression but you don't have the sign there? What do you call a multiply algebraic expression when there's not a sign? Lincoln? Coefficient. It's called a coefficient. It's called a coefficient. This joker is a coefficient. Is this a coefficient? 1 plus x? No. Is this a coefficient? X minus x? No. Is this a coefficient? 2y? Yes. So I'm just literally saying there's 2 of the y's. That's what I'm saying. Okay, on page 429 at the very bottom, will you please come up with a way to rewrite number 1 and 2 as the multiplication of the addition? So in number 1 and 2 at the bottom, take the addition and make a multiplication. For example, if I said 2 plus 2 plus 2, you'd say that's 2 times 3. You'll do that to number 1 and 2 at the bottom. And you got 2 times 14, right? And you got 3 times 92. Go ahead. Top of page 430. Izzy, top of page 430. Will you read me what it says about expressions, how they can be written? Go ahead, Josiah. Hang on, let Josiah sharpen his pencil. Anybody else need sharp your pencil? Okay, go ahead.
So the question is, what's not the product of a sum? For example, 2 times 3 is 4. So the product of 2 is not equal to 4. The expression 2 times 3 equals 4 can also be bought as a product of a factor.
All right, so go ahead, you guys. Then we'll go to sharp your pencil.
Thanks.
Thank you. What's the matter? Do you sharp your pencil? No? I thought you raised your hand. All right. Y'all see this, right? We all agree that order of operations would say, I say 3 plus 4 is 7. 7 times 2 is 14, right? Does everybody agree? 3 plus 4 is 7. 7 times 2, 14. Okay? We can use distributive property and factor it out and get the same answer another way. You're like, why would we? Because that's the shortcut. That's right. But we're going to have to when there's letters involved to figure out what the letters are. What I mean by that is this. Let's literally write out what this says as a story. And it's money. All right? So here's my story. I earned $3 for putting away the the clothes. I earned $4 for cleaning up the kitchen. That happened on Monday and on Tuesday. I now have $14. How did I get $14? Well, on Monday I got 3 plus $4, $7. I did that 2 days, 2 times 7, 14, right? But that 3 represents something. That 4 represents something, right? So I'm going to literally draw that out for Monday and for Tuesday. Okay? So here's Monday. 3 plus 4. Here's Tuesday. Easy, you're not writing down. 3 plus $4. Right? So Monday I earned a $3. I earned that same $3 on Tuesday. I earned a $4 amount on Monday. I earned another $4 amount on Tuesday. So I could go 3 plus 4 is 7, plus 3 is 10, plus 4 is 14. Or I could say on Monday I earned $7. I repeated it on Tuesday. It's 2 sets of 7, right? But this is another way to look at it. Saying, oh, 2 sets of 3 and 2 sets of 4. Because this 2, okay, here's the part you got to know. Distributive property. This 2 is multiplying by this 3, right? Everybody agree? Okay, if you're not 100% listening to me right now, you better. This is super important. From now through Fume Fog, you're going to be doing this all the way through Integrated Math 4. Much harder than this, but this same idea. This 2 is multiplying through that 3, but it's also multiplying through that 4. You're like, yeah, because I got $4 both days, right? But I got $3 both days too. So it's 2 times 3 plus 2 times 4. So I can factor this down to 2 days of $3, right? Plus 2 days of $4. That's another way to see it. Now, it's okay if you don't get all of that right now. I'm just showing you the connection of the whole piece. We're going to go through each little part and talk and practice and work for a while, because this is new stuff. Okay? So let's try another one of those. Okay? Monday, Tuesday, and Wednesday, I earned some money. I earned $1.50. I earned $1, and I earned $2. I earned $1.50 for standing up, earned $1 for sitting down, and I earned $2 for being quiet. Okay? On Monday and Tuesday and Wednesday. How much money did I earn on all 3 days? Go ahead and figure that out. Multiple ways to get it. When you know how much you earned, text me the number of the money. Just text me the money. Just the answer. Text me how much you earned. tell me how much you earned on all 3 days.
Yes.
Each day you earned this much money for 3 days. Sum of all that. I did it as a product and a sum. This you can just do. Sum. Send me the answer. Text me the answer. For all of them. Did you say you earned $13.50? Anybody earn $13.50 doing that? Did you say, oh, 2 plus 1 is 3, 3 plus 1.5 is 4.5. 4.5 plus 4.5 is 9, plus 4.5 is 13.50, or 3 times 4.5. Who did that? Some variation of that. Okay, here's what I did. Is that okay? Didn't I on Monday get $1.50 for standing up? 3 days of that? Didn't I get $1 for sitting down 3 days? Didn't you get $2 for 3 days of being quiet? Isn't that $13.50? All I did was I distributed out 3 times this, 3 times this, 3 times this, add all that together. That's what you call factoring. Using distributed property. Okay? It's okay if you didn't think to do that. I don't expect you to think to do that. Did anybody do that? Okay, good. Was that? You do that to check your work. Yeah. She checked her work that way. Now, in real life, are you going to factor that out? No, you're going to do, that's less efficient. That's more efficient to do order of operations, right? That's why we have it. But you have to understand it breaks down and factors out this way, because when you're doing it, if I throw an X in here, you can't use order of operations anymore. You got to factor it out. That efficient way of using order of operations for algebra, where there's a variable thrown in, won't work. You got to do this. But you need to see how it works with just numbers first, right? That's why I'm showing you that. Because when an X is involved, or whatever variable, you're going to have to factor it out and use distributed property to come up with what the answer is. So what if I told you I get $1.50 for standing up, I get an envelope with amount of cash in it for sitting down, and I get $2 for being quiet? How would that problem look different? I got the $1.50 for standing up, I got an envelope with the cash in it for sitting down, and I get the $2 for not talking. How's it going to look different, Mellis?
It would say 1.5 plus X plus 2.
That's right. Because the envelope with the cash in it, that I get that cash every day, the envelope has the same amount each day, is the unknown. I don't know that's $1, right? Until I do distributed property and find out it all equals $13.50, then I can solve for the X. Okay? That's algebra. Okay? So that's what we're talking about. Again, that's the big picture. Okay, let's go on page 430. Okay, step 1 on number 2 there. It says Melina and Kendrick are selling tins of cashews for a school fundraiser. She sold 5 on Monday and 5 on Tuesday. Kendrick sold 4 on Monday and 4 on Tuesday. Label the Monday and Tuesday to show Melinda's and Kendrick's. On step 1 of number 2, make the bar for Monday and the bar for Tuesday represent Melina's amount of money, or boxes, or whatever it was, tins, and Kendrick's. When you have done that, if you will send me a picture of just that, please.